Hello techies. So today in this video we will discuss about the use of capacitor in circuit design. There are multiple applications in which capacitor is used, and we get often confused that which we use capacitors but we don't know uh, like how to use the capacitors. We know the basic thing that capacitor is used as a filtering circuit, and so most probably the common uh, or the famous circuit for capacitor is RC filter. But other than filtering circuit, there are other applications also uh, for capacitor in circuit design. So in today's video, we will discuss that how we can use this capacitor um, in various applications. So if you see this uh, simulation window, here I have drawn three circuit which is representing uh, capacitor application. So the first circuit is coupling circuit, the second circuit is decoupling circuit or a smoothing circuit or filter circuit, and the third circuit is powering circuit. So that means capacitor can also be used as temporary power transfer or temporary charge transfer. So what does this coupling and decoupling means? So as you can see that I have used AC voltage source here with a DC offset, 100 kilohertz frequency and 50 amplitude. So this is example of coupling circuit. As you know that capacitor can only block DC voltage and passes AC voltage. So that means that if we have any AC source or AC voltage in which there is DC mixed or any DC offset is added, so we can put capacitor in that in series of that voltage source to block the DC voltage, and we will get the final AC voltage here without any DC source. Similarly, decoupling means we need to remove the AC signal and block and output the DC source. So that means that we are using capacitor to the ground, connected to the ground. That means that any AC source or any noise or any kind of transient coming in this voltage source will be transferred to the capacitor and thus to the ground, and depends from the ground where it goes to the it probably goes to the major voltage sources, but that is different topic where this noise goes. So the noise is transferred to this capacitor, and in the output we will get DC voltage as a pure form of voltage. Similarly, this temporary power circuit, and this is quite understandable circuit. Here I have used NMOS, here I have used PMOS. I am giving 5 volt. When one turns on, other turns off. When other turns off, other turns on. That means NMOS and PMOS operates in complementary fashion. So when NMOS turns on, this will turn off. In that case, capacitor will charge, and when NMOS turns off, PMOS will turn on. In that case, capacitor will be discharged. So charging and discharging cycle depends on time constant. That means RC charging circuit time constant and discharging circuit time constant. So this is also a separate topic, how to design charge and discharge circuit. Coming back to decoupling circuit, so as you can see, this is R and this is C. So there is an RC filter which is also used as a low pass filter. That means 0 hertz frequency is passed mode and high frequency is suppressed mode. Actually, these are not suppressed, but these are transferred to other path, not to the output. So in another video, we will discuss about that how to design this RC filter so that we can get maximum DC voltage here without any AC noise, and we appropriately select this capacitance there and also the R battery here. So I will run this simulation quickly and show you how this circuit behaves. So my circuit is completed, and let's see. So first I would like to show you the nature of the circuit. So let me guys reduce the time transient value for this. Let us take 0.1. Even 0.1 millisecond is also too much. I'm not sure. I'm just putting 1 millisecond here, and the simulation continues to run. Maybe I can run it again, or let me check whether I can shift it to here or not. Okay, okay. This circuit is still running. I don't know what's the issue here, but nonetheless, let's draw the waveform. Well, I can add maybe millisecond. Okay, I don't know what's the issue. Okay, okay, maybe I have copied extra. Actually, let me find out this problem. By the way, should I close this and then run again? Okay, now it is asking for. Now I will take 1 millisecond. Okay, it's Ltspice simulation. You know that it gets crazy by its own. So, nevertheless, let's move on to the schematic simulation. So I have plotted AC voltage source here. As you can see, there is an offset of 10 volt. So since this is decoupling, that means that uh, we will get output of DC only. So let's see how much voltage we get. Okay, so we get output voltage of around. So if you take average of 10 volt, so average is almost 10 volt because uh, AC is removed. So we can more clarify this by increasing this capacitance value. So now you can see that capacitance is like 9 volt to 10 volt. So what I can do here is I can increase this to 20 volt, and this also, let's say, 5 volt. So this is the output voltage that we will get, and as you can see, ripple is very less in this voltage, so we are getting mostly DC voltage at the output. So that means that AC is removed. Now we are getting DC at the output. Okay, now similarly here, now this is coupling circuit. That means DC will be blocked and AC is will be at the output. In that case, since DC is blocked, so we should get 0 volt here. So there should be no DC offset. All right, you are not getting any DC. Uh, okay, now let me tell you one more thing. Since this current is sorry, this resistance is very low, that means current is flowing very high. So if I increase this to 20, then now you can see that voltage is increased at the output, and average voltage, if you want to see, average voltage is almost zero. So this is quite evident from the simulation that putting capacitor in series blocks the DC and can remove the DC voltages in the AC source. This circuit is also helpful in transformer desaturation. For example, uh, we can put one capacitor in this series so that no DC is passed like this. So you might have also seen in some of the uh, schematics that a small nanofarad capacitor is placed uh, in the windings, and that is also in series. So anyways, so this was the topic for today's video. The main discussion was to make you understand that capacitor in series with AC source blocks the DC, and capacitor in parallel with AC source transfers the AC to the ground and can act as a smoothing circuit or smoothing voltage filtering circuit, or whatever you want to call it. So in the next video we will discuss how to design this RC filter so that we appropriately choose this C value and R value. Thank you guys.